In today's lesson, we are going to learn how to find the derivative of some function f at x from first principles. When we say we find the derivative of some function using or from first principles, we mean that we are going to find the derivative of that particular function by applying this formula. This formula says that for some function f at x, the derivative of f at x, which we read f prime of x, is given by the limit as h approaches 0 of f at x plus h minus f at x over h. Let us have an example of how you apply this formula. Let's say you've been given a function f at x equals to 6x squared, and you are required to determine the derivative of this function from first principles. Now, the first step is to write down the formula that we use to find the derivative. Now, if you look at the numerator of this formula, it says that whenever I find x in f at x, in this first term, I should replace it with x plus h. Then I subtract the whole f at x and divide this by h. Let us apply this in f at x. If you look at f at x, I only have one instance of x, which is x squared. Then in this first part, I'm going to replace x with x plus h. Then I subtract 6x squared. Now my next part is to expand the brackets. How do we do that? You expand the brackets to arrive at x squared plus 2xh plus h squared, which we can further simplify to arrive at 6x squared plus 12xh plus 6h squared minus 6x squared. If you look at the numerator, I have 6x squared minus 6x squared. The two will cancel out each other. Now I'll be left only with 12xh plus 6h squared. If you look at the main point of this exercise is to simplify the numerator as far as possible so that the terms in the numerator, all the terms in the numerator contain h. Now what we have done so far, we have cancelled out 6x squared minus 6x squared, and we are left with terms that contain h as the common factor. Now why we do that is so that we can take out h as a common factor out, so it can cancel out the h in the denominator. Remember, we are trying to find the limit as h approaches 0. So if we substitute h equals to 0 in this expression will be undefined because division by 0 will be undefined. So the idea is that we simplify the numerator, we are left with terms that contain h, we take out h as the common factor, then the h cancel out with the h in the denominator as follows. We took out h as the common factor, and this h and that h will cancel out, and then you'll be left with just 12x plus 6h. Now we can take out the limit as h approaches 0 by substituting h equals to 0 whenever we see h in this expression. We have substituted h equals to 0, and then we got 12x. What this means is that the derivative of 6x squared is given by 12x. Let's try another example. In example 2, let's say you've been given f at x equals to 2x squared minus x, and then you're required to find the derivative of this function from first principles. The first part is to copy the formula and you do the substitution. Now if you look at this function, it's not like the one we just did previously where we only had one term, which was just 6x squared. In this case we have two terms, and then we have two instances of x here. I have x squared and I have x. Now according to this formula, in the first part I need to replace x with x plus h. Look at what we did here. In x squared, 2x squared, I replaced x with x plus h. In minus x, I replaced it with x plus h. Then I subtracted the whole f at x there. Now you can go ahead and simplify the whole expression to arrive at this part where you have 2x squared plus 4xh plus 2h squared minus x minus h minus 2x squared plus x. If you look at the numerator, 2x squared minus 2x squared will cancel out each other, minus x and x will cancel out each other. The terms that will be left with will all contain h. All the terms contain h. We have 4xh plus 2h squared minus h. Then we can take out h as a common factor, so it can cancel out with the h in the denominator, and we'll just be left with 4x plus 2h minus 1. Now, if we take the limit as h approaches 0, by substituting 0 whenever we see h, then we will be left with 4x minus 1. Therefore, the derivative of 2x squared minus x equals to 4x minus 1. Let's try example 3, in which case we have the square root of x as f at x, and we are required to find the derivative of this from first principles. Please feel free to pause the video and try it yourself. Like in the previous problems, the first thing is to write down the formula for finding the derivative from first principles, and then you substitute accordingly. Where there was x in the first part, put x plus h. Now, the way we approach this problem of finding the derivative of the square root of x from first principles is to rationalize the numerator. Try to rationalize the numerator by multiplying by 1. What I mean by that is we rationalize the numerator by multiplying by 1. These two, when you multiply these two, this is just the difference of two squares. You'll be left with x plus h minus x. And if you look at the numerator, x and minus x will cancel out, and the numerator will just be h. Remember, the idea is to make sure that the numerator contains terms with h and h, with h only, and then h and h here will cancel. Even if we were to take a common factor, we only have h, so therefore h and h will cancel out, and therefore this is what will be left behind. Now, we can test the limit as h approaches 0 by substituting 0 whenever we see h in this expression. If we do that substitution, we'll be left with 1 over 2 the square root of x. Therefore, the derivative of the square root of x is simply 1 over 2 the square root of x. As the last problem, let us try a situation where x is the denominator. Let's say you've been given f at x equals to 1 over x squared. Even here you can pause and try it yourself. To solve it, like in the previous problems, start with the formula, do the substitution, and then the simplification. Now look at what I did here. This is my approach. I took the numerator, found the lowest common denominator, which is x squared in x plus h squared, and then I simplified it to give me what I have here, all over h. So the next part, I actually found the multiplicative inverse of h. Instead of dividing by h, I multiplied by the multiplicative inverse. Then I expanded x plus h like in the previous problems. Therefore, I arrived at this. Now x squared minus x squared will cancel out. I'll simply be left with 2x minus 2xh minus h squared in the numerator, which is minus 2xh minus h squared. If you look at the numerator, I can take out h as the common factor. If I take out h as a common factor, the h in the numerator will cancel out the h in the denominator. And then this is what will be left behind. Now I can test the limit as h approaches 0 by substituting 0 whenever I see h, and that leads me to minus 2x as the numerator over x to the power 4. X and x in the numerator can cancel 1x here to be left with minus 2 all over x to the power 3. Now what this tells me is that the derivative of 1 over x squared is minus 2 over x to the power 3.